Let's follow a customer's aircraft component, which needs to be overhauled, through the shop to get an introduction to what FlyRite does and an overview of the role you play in the process. First, an aircraft owner or operator ships their component to FlyRite's office. Our team receives the component and creates a customer order and job work order. This process looks at what the customer's needs are, including the date they will need their component, so that they can continue running in a safe and competitive way. To be in line with the regulations, the team member will note the time since the last overhaul, as well as gather the component's history and specific maintenance instructions. They also make sure the component is properly identified and tagged, and that it can be traced back to the last airworthy installation. This information is recorded on the work order, and once all is in order, the team member prints a Component Inspection and Test Record Form, or CITR for short. A team member then puts the work and the component in a job tub and moves it into the holding area. Once there, and before any shop work begins, a shop technician performs a verification step, double-checking that the unit's serial number matches the work order and that the customer's requirements are clearly marked and understood. A shop technician then prepares to start maintenance on the component by reading the work order and getting the component maintenance manual from the tech library. Throughout the entire maintenance process, the technician will continually make sure that the parts of the component match the work order number and that they return to the correct job tub. After a brief inspection to learn about modifications and service bulletin status, the technician disassembles the component according to proper procedures. All parts that need to leave the job tub are tagged or labeled so that they can be tracked throughout the process of stripping, cleaning, inspecting, painting, repairing, and testing as appropriate before reassembly. With the component disassembled, the technician uses proper processes to remove paint and to wash and oven dry the various parts of the component that require it. Some parts may go out for magnetic particle inspection, and those must be cleaned, documented, and packed for the process. Once cleaning is completed, the parts are reunited in a clean job container where they will head to inspection. The technician will then use various measuring tools and equipment to examine and check critical dimensions and other properties. They will also check whether electrical components work or require repairing. Any defects or added needs are recorded on the Additional Work Required, or AWR form. At this point, a shop certification authority double-checks the inspection, paperwork, and added needs for work and parts. They will also confirm whether there are related notices that would affect the unit's repair and overhaul. If necessary, they will prepare a service difficulty report, which is required for any reportable issue discovered in servicing the component. They will also prepare a quote for the customer and, when needed, get the customer's approval before work continues. Any surfaces that need treatment, painting, or refinishing receive it at this stage, while the commutator and armature are being overhauled. A team member will assemble and record traceability information for any parts needed out of stores for the repair and overhaul. Then, the technician will follow the component maintenance manual and FlyRite shop procedures to perform repairs and overhaul the component's parts. This includes using a lathe and undercutting saw on the commutator of the armature. The technician will then ensure that the armature is balanced and use a mill to fix any balance issues. On the clean side of the shop and away from the mill, lathe, and saw, the technician assembles the component for testing. FlyRite uses specific shop parts for testing, so the customer's parts aren't subjected to wear. The technician will seat and run in the brushes. The brush is the part that conducts current between stationary wires and the rotating armature. The assembled component is then put through several tests to ensure quality and safety. The first series of tests make sure the component can operate at the correct speed, generate enough current, and won't overheat. Other tests include a locked rotor torque test or an accelerator test and vibration check. The technician will perform these tests and record the results, making sure they are within the manufacturer's specifications. Once the component has passed all tests, the technician removes all shop parts for final assembly. After making sure all parts are installed and listed correctly, the Shop Certification Authority, or SCA, reviews all work and conducts a final pre-closing inspection. While the technician finishes assembly and attaches any safety parts for shipping, the SCA prepares all the final records and documentation. The SCA prepares the authorized release certificate and closes the work order. The completed component and paperwork moves to shipping, where a team member does a final check of the paperwork and makes file copies. Then, the component is safely packaged for travel, and the component is shipped back to the customer. Included in the shipment are the component certification documents, which say what work has been done and that it is safe for use on an aircraft.